Just say it, man. Don't make me ask 20 questions.
What is the point?
Get to the point.
Just say it already.
Welcome to the Podcram. Andrew Huberman explains the vagus nerve.
The autonomic nervous system is a seesaw where the levels of alertness and calm that we experience at any one moment reflect the relative balance of sympathetic nervous system and parasympathetic nervous system activity. They're sort of in a push-pull with one another. Increase the parasympathetic nervous system activity a little bit, you get a bit calmer. Increase the sympathetic nervous system activity a little bit, you get a bit more alert. But they're always both active. The vagus nerve is classified as a parasympathetic nerve. However, it's a bit of a misnomer because, as you'll soon realize, there are pathways within the vagus nerve that were you to activate these pathways within the vagus nerve, you would become more alert, not less alert. This is one of the things that I'm hoping to dispel through the course of this episode, which is this very common myth out there. It's almost pervasive that when you activate the vagus nerve, you're going to calm down. It is simply not true. Okay, there are instances where that is true. There are instances where the opposite is true, depending on which branch of the vagus nerve you happen to activate or suppress. If you're asked on an exam, students, med students, I don't want to be responsible for you getting this wrong. I'd love to be responsible for you getting it right. I teach neuroanatomy to medical students. If you are asked, is cranial nerve 10, the vagus nerve, parasympathetic or sympathetic, you should answer parasympathetic. If you're asked if it's sensory or motor, you should say it's mixed. It's both. So it's mixed parasympathetic. However, for everybody out there, med student or not, just understand that when you activate certain branches of the vagus nerve, you're either going to get an elevation in alertness, that is an increase in sympathetic nervous system activity, or a decrease in alertness, that is an elevation in parasympathetic activity, depending on which branch you activate, and the context matters. I'm now going to tell you a tool that you can use when you're feeling less than energized, less than motivated, and when you need to exercise and you don't feel like doing it. And when you want to leverage exercise as a way to improve brain function and plasticity. It all involves the vagus nerve, and it involves an aspect of the vagus nerve that very few people are aware of, but in my opinion, is one of the coolest aspects of the vagus nerve. It's at least as cool as vagal control over heart rate variability and autoregulation. And it goes like this. There's a beautiful set of findings from a guy named Peter Strick at the University of Pittsburgh, who used these really cool methods for tracing connections between the brain and body to ask the question, what areas of the brain are communicating with our adrenal glands? Our adrenal glands are two glands that sit atop your two different kidneys, so one atop each kidney, and release, as the name suggests, adrenaline. Adrenaline is also called epinephrine. Your adrenal glands also release cortisol, but for sake of this discussion, let's just think about adrenaline released from your adrenals. What he found through a bunch of experiments done in non-human primates, and that seem to correspond very well to what we observe in humans as well, is that there are three general groups of brain areas. Motor activation areas, so what we call upper motor neurons. So these are the neurons in the brain that control the lower motor neurons in the spinal cord that control the muscles of the body, as well as neurons within our brain that are involved in cognition and planning, and areas of the brain that are involved in emotion that can communicate with the adrenals and cause them to release adrenaline. Now that's great, but it sort of points to a pathway whereby, okay, you know you should exercise, you tell yourself you should exercise, you're emotional about it, and your adrenals release adrenaline and you exercise. Now that's interesting, but what's perhaps far more interesting is that the data from Strick Lab and other labs as well shows that when we move the large muscles of our body, the adrenals release adrenaline, epinephrine. Now, epinephrine has an activating sympathetic nervous system stimulatory effect, right? It tends to make the tissues of the body that are associated with movement and with so-called fight or flight, although again, fight or flight is kind of an extreme example. It tends to activate the organs of the body and make them more likely to be active. It increases the probability that movement will occur, overall body movement. So when we move the large muscles of our body, our legs, and in particular our trunk muscles, we release adrenaline. That adrenaline activates the organs of our body and further makes it likely that we're going to move our musculature more. But get this, adrenaline, epinephrine, doesn't cross the blood-brain barrier. So how does it increase our level of alertness in our brain, right? You don't want your body to be super active and your brain to be kind of sleepy. That's not good. That's not adaptive. Turns out that when the adrenals release adrenaline, it binds to receptors on the vagus nerve itself, those sensory axons that extend into the body. There are receptors on those wires, right? Not all the receptors are at one end or the other. They're also on those axons. The adrenaline binds to the receptors on those axons, and the vagus nerve, in turn, releases glutamate, an excitatory neurotransmitter, in a structure in the brain called the nucleus tractus solitarius. The neurons in what I'm just going to call the NTS for simplicity, in turn, activate neurons in a brain structure called the locus coeruleus. The locus coeruleus contains neurons that release what's called norepinephrine. And the neurons of locus coeruleus send their axons out very extensively across the brain in kind of a sprinkler system-like organization, such that when you move the large musculature of your body, you release adrenaline. That adrenaline activates the tissues of your body, makes them more likely to move, also binds to receptors on the vagus. The vagus nerve in turn releases glutamate, an excitatory neurotransmitter in the NTS. The NTS then passes off that excitatory signal like a bucket brigade off to the locus coeruleus. The locus coeruleus dumps a bunch of norepinephrine into the brain and increases your levels of alertness. What this means is that the vagus nerve is central to the process of using physical activity to make your brain more alert. And we know that activation of locus coeruleus makes the brain areas that are involved in motivation and the propensity to move more higher in levels of activity. In other words, if you're not feeling motivated to exercise or you're not feeling alert enough, movement of the body that includes especially the legs, the large muscles of the legs, so quadriceps, hamstrings, etc., as well as the trunk muscles of the body, stimulate this pathway in a kind of dominoing effect that makes the likelihood and, believe it or not, the desire to move much more likely. This I've personally found to be an immensely useful piece of information because sure, I knew that sometimes I would go to the gym or I'd head out on a run and I wasn't feeling motivated, or I'd sit down to do some work and I'd feel kind of sleepy despite the fact that I'd slept pretty well the night before and eaten just fine and the room wasn't too warm, etc. I feel kind of lethargic. And I was like, what's going on here? And yes, I had the experience of sometimes, doing a bit of a warm-up, maybe some light calisthenics, maybe a few warm-up sets or jogging for a little while and then finding that my levels of alertness increased. But I've also had just as often the experience of not feeling that motivation for physical activity or for cognitive activity come online, especially if I wasn't extremely interested in that activity or that thing that I was supposed to learn. It's very easy to be excited when we want to do the activity or we want to learn the thing that we're supposed to be learning at a given moment or reading at a given moment. This pathway is immensely useful to understand because it explains why it is that even when you're not feeling motivated, if you do some activity that, yes, is preceded by a bit of a warm-up. So maybe, you do some light calisthenics or you go on the treadmill for a few minutes, walking, then maybe a little bit faster, that it can increase your levels of alertness and motivation. But it especially explains how if you put in some effort that at the moment feels like a big exertion, your entire body and brain state shifts in a way that levels of motivation and energy to do more physical work or more cognitive work or both increases dramatically. And these are not small effects when they've been measured. In fact, for all the talk that's out there in kind of pop psychology and in kind of pop neuroscience about the vagus being a calming pathway, all the neurophysiologists out there, and I know there aren't very many, but I'm friends with a lot of neurophysiologists, they'll all tell you that if they're doing a surgery or they're doing some sort of brain recording and the animal or person that they're doing the brain recording from is starting to drop into a state of kind of deep parasympathetic activity, they're falling asleep or they need to be more alert, what do? They stimulate the vagus. They stimulate the vagus nerve in order to wake up the brain. In fact, stimulating the vagus has been used to save people's lives when they are drifting too far down into deeper and deeper planes of anesthesia. So stimulating the vagus wakes up the brain. And the way to stimulate the vagus is by way of these receptors on the vagus nerve itself. And the way to do that without an electrical stimulator, right, because we're not talking about clinical conditions here, in order to increase levels of motivation, alertness, and focus for physical activity or cognitive activity and learning, etc., or simply to overcome lethargy and brain fog, is to do some sort of physical activity that includes the large musculature of your body. These could be things like jumping. These could be things like actual resistance training. This could be running. This information really points to the idea of course, after a good warm-up, doing more sprinting type activity, more strength type activity, 6 repetitions or less, where you're getting close to failure, this sort of thing, to wake up the brain and body, as opposed to doing long rhythmic activity that's below the threshold of what would activate a lot of adrenaline from the adrenals. So the idea is to get those adrenals to release adrenaline into your system. It won't cross the blood-brain barrier, but your vagus nerve provides this beautiful link between the body and brain to match levels of excitation from the body to the brain, and you can leverage that. In addition, there's also the well-described effects, and I've done an entire episode about this, of how exercise can improve brain plasticity and the ability to learn. And while there are a host of mechanisms involving long-term changes in things like brain-derived neurotrophic factor and increases in lactate, which might open the door to plasticity and so on and so forth, it does seem that one of the major ways that exercise improves our brain function and our ability to learn is simply by increasing our levels of alertness. And I should say the word simply placed in there is probably a bit unfair. There is absolutely nothing trivial about using exercise as a way to stimulate a sort of cascade of this neural circuit from the adrenals up the vagus and into locus coeruleus in order to wake up your brain networks that are involved in motivation, focus, and learning. As we'll talk about in a few minutes, many of us, most of us perhaps, are used to using pharmacology like caffeine or other stimulants in order to try and wake up levels of alertness in the brain. And I'm not being disparaging of that. I am an avid consumer of caffeine in the form of yerba mate or coffee. I'll occasionally take an alpha GPC or an L-tyrosine as well. I do all those things. However, in my opinion, it's far more powerful to be able to leverage, that is, to activate these levels of alertness in your brain and body in a way that doesn't require any pharmacology. If you don't have it available to you, or you're trying to avoid pharmacology, or you're working out late at night, or you want to focus later at night, you don't want to be kept awake by the caffeine, or even if you consume caffeine or other stimulants, knowing the organization of these neural circuits from the body to the brain and how they match levels of alertness and leveraging them is so straightforward, but most people don't actually get to the point where they're doing that high intensity work or they're doing the work that involves the large musculature of their body when they're feeling not motivated. In fact, they usually do the opposite thing. Now, sometimes you need rest days. This is true, right? You need to rest and recover to make progress. You don't want to exhaust yourself. You need to get sleep. You need to take care of yourself. However, the reason we're talking about this is it's a beautiful opportunity to A, explain that the vagus nerve is not just about calming down. It's actually actively used to wake up your brain when your body is active, when the large musculature of your body is active. And B, that like with autoregulation, this stuff is under conscious control. Yes, if you were to be frightened immediately, this is the same pathway that would be reflexively activated by an intruder or by, a big explosion or something of that sort. Your body would wake up, release adrenaline, then that adrenaline would set up along this cascade and your mind would be immediately alert as well. There's some parallel mechanisms too to make sure that your brain and your body are alert immediately. But when you start to understand what these pathways are and that they're very specific and very powerful, potent inroads into activating these circuits, it does indeed give you a tremendous amount of agency, especially for those of you that might think you're not motivated to exercise or you're always lethargic or you have brain fog. There might be other reasons for that, but for many people, chances are you're not getting past that threshold whereby these circuits involving the vagus can be activated. And now you know how. So activate them.
Thanks for listening to this installment of The Podcram. I hope it contains something useful for you. If you enjoy these selections and are curious about the curator's own thoughts, you can check out my other podcast, Psychic Lube, where I share concise concepts meant to grease the intellectual gears and help get your creative juices flowing. Each episode is an ongoing collaborative project that welcomes listeners to expand or rebut its points by email or comment, the most interesting of which get incorporated through periodic re-recordings. As always, if you're intrigued by today's content, I encourage you to go listen to the full podcast in its original form directly from its creators so that their sponsors keep paying them to make stuff for us and nobody feels compelled to sue me for copyright infringement. Now, get off your phone and go do smart stuff. Have a productive day.